Okay, so in this lesson, we're going to graph quadratic functions, and the quadratic functions that we're going to graph in this lesson will be functions that are in standard form. Not vertex form, but standard form. And remember, standard form looks like this, g of x or f of x, whatever the function notation may be, and it'll be ax squared plus bx plus c. All right, so that's standard form. All right, so we're going to graph quadratic functions of that form. In a previous lesson, you graphed quadratic functions that were in vertex form. Okay. All right. Now, so what we're gonna look at are problems that look like this. So it says for each quadratic function, graph each quadratic function, and if necessary, we're going to round the x-intercepts to the nearest tenth. All right, now this looks very similar. The format looks very similar to what we did previously when these quadratic functions were in vertex form. All right, now in a previous lesson, you learned how to find the vertex of a quadratic function that was written in standard form. So let's kind of review that. So if a quadratic function is written in standard form, to find the vertex, you must always find the vertex when graphing. So to find the vertex, remember the vertex is hk, and remember h is the x coordinate, k is the y coordinate, and so to find h, you're going to say negative b, the opposite of b, divided by 2a. So that's how you find h of the vertex, the x coordinate of the vertex. Remember, that's the x coordinate right here. Okay? Now, remember, a and b, remember, a is the coefficient of x squared, and b is the coefficient of x. So in terms of finding the x coordinate, c is not needed. Now you're going to need c to find the y coordinate. That's obvious, but to find the x coordinate, you just need a and b. So negative b, the opposite of b, divided by 2a. All right, now once you find h, once you find the x coordinate, remember this is a function, so once you find the x coordinate, to find the y coordinate, you just substitute wherever you see the variable x, you're going to substitute what you just found. So basically, in other words, and remember this was in a previous lesson, so in other words, to find the y coordinate, you're basically saying this. If this is the x, then to find the y, you're going to say g of h. So where we see the variable x, you're going to substitute whatever h is that you just found. Okay? All right, so that's how you're going to find k. So to find k, whatever h is, you're going to substitute. All right, so let's see how this looks. So let's go back to now this part's a review from a previous lesson, because in the previous lesson you did find the vertex of quadratic functions that were written in standard form. All right, so this will basically be a review. The only new part here will be how do I find the y-intercept, how do I find the x-intercepts, and then what do I need to graph. Okay? All right, well, to graph, you're definitely going to need the vertex. So let's find the vertex of this function. All right, so I'm going to go and do this here. So number one, my function's this, f of x equal 2x squared plus 4x plus 3. All right, so 2x squared plus 4x plus 3. All right, first thing we got to do is find the vertex. So when graphing, you must always find the vertex. So the vertex, remember the vertex is hk, and to find h, I'm going to say the opposite of b divided by 2a. All right, so it helps if you denote what a, b, and c are. So a is a coefficient of x squared, so that's 2. b is a coefficient of x, so that's 4. And c is your constant, and my constant's a positive 3. All right, so I go and I substitute. So if h is 4, then the opposite of 4, if b is 4, then the opposite of 4 is negative 4, divided by 2 times a is 2. So I get negative 4 divided by 4, which is a negative 1. So I found, in terms of the vertex, I found the x-coordinate. So the x-coordinate of my vertex is negative 1. Now to find k, which is the y-coordinate, all I do is wherever I see the variable x, I substitute 1 because that a negative 1 because that's what my x-coordinate is. So to find k, you're going to say, this is f, you're going to say f of negative 1. And so that becomes 2 times negative 1 squared. So where we see the variable x, you substitute negative 1, plus 4 times negative 1, plus 3. And so negative 1 squared is 1. 1 times 2 is 2. 4 times negative 1 is a negative 4, plus 3. Combining like terms, I get 2 subtract 4. Remember, order of operations, go from left to right. 2 subtract 4 is a negative 2. Negative 2 plus 3 is a positive 1. So my vertex is negative 1, 1. That's your vertex. All right? So the vertex is negative 1, 1. So in your mind, this is what you know so far. In your mind, this is what you know. And so is it going to think like this, like I'm about to do? So I know that my vertex is negative 1, 1. So negative 1, 1 is in the second quadrant, right? Okay. And I know that my quadratic function, my parabola, is going to open up. And the reason I know it's going to open up is because A is positive. So it opens up since A is positive. Okay? All right. Now it opens up since A is positive, so I know it's going to do this. That's what it's going to look like. Okay. So keep that in mind. All right. Number 2. I'm sorry. The next thing you want to look at is the domain, range, the y-intercept, and the x-intercept. Okay? All right. Now remember, we talked about this before. Whenever you have a quadratic function, you'll notice that either the parabola is open up or the parabola is opening down. The domain is going to be all real numbers. So as you go from left to right, every value of x is going to be on this parabola. So the domain is always going to be all real numbers. So in this one, you'll say negative infinity to infinity. And remember, the vertex here is negative 1, 1. All right, now let's talk about the range. So you see that the vertex is in the second quadrant and that the vertex is negative 1, 1. And to find the range, remember what we did, we go along the y-axis and I start touching the graph at this minimum point, this vertex. That's a minimum point. That y-coordinate, remember the range is a set of y-coordinates, that y-coordinate is 1. All right, and so remember, with domain and range, there are times when you're going to need brackets, times when it's going to be parentheses. So remember, with infinity, negative infinity, always use parentheses. Now, since this point is on the graph, you're going to need a bracket. So you're going to say bracket 1 to infinity. All right, now let's talk about the y-intercept. Okay, so remember the y-intercept is where the graph crosses the y-axis. And no matter where you are, when the graph crosses the y-axis, no matter what function you're looking at, whatever the y-intercept is, notice that the x-coordinate is always 0, regardless. The x-coordinate of all of these x-intercepts, whatever the function looks like, whatever it looks like, the y-intercept, the x-coordinate is always 0. So to find the y-intercept, remember, you're going to let x equals 0. All right, so you go to your function, and wherever you see the variable x, you're going to say 0. So basically, you're finding f of 0. That's what you're doing. So I get 2 times 0 squared plus 4 times 0 plus 3. But what I want you to notice is this. Whenever it's written in standard form, and remember, you're letting the x be 0, right, to find the y-intercept? Whenever it's in standard form, notice that when x is 0, this term becomes 0, this term becomes 0, and you're just left with your constant. So it turns out that this constant here, again, this only applies if it's in standard form. If it's in vertex form, that's not true. All right, so only in standard form. So this constant here is 3. That happens to be your y-intercept because this is 0. This is 0. So 0 plus 0 plus 3 is 3. So my y-intercept as an ordered pair is 0, 3. So that's your y-intercept, 0, 3. Okay? All right, now, so far, in terms of the graph, let me just kind of show you what's happening. So in terms of the graph, so far, this is what we have. All right, so this is what we have so far. So I know that the vertex is -1, 1. So -1, 1, that's here. I know that the graph crosses the y-axis at 3. So that's your y-intercept. All right, now remember, just like in a previous lesson, you are going to draw the axis of symmetry to help you. Now remember, you want at least 5 points on here to help you draw a parabola. All right, so your axis of symmetry, remember, always goes through the vertex. So just draw a dotted line to help you to draw. And again, it doesn't look straight because I've kind of messed this up. All right, but here's the axis of symmetry. All right, now remember, just as before, so here's my vertex. Here is a point. Here's the y-intercept. So remember the distance. So remember the parabola is symmetrical about the axis of symmetry. So if you were to fold it, this side should overlap with that side. All right, so keep in mind in a previous discussion that this idea. See how the y-intercept is 1 unit from the axis of symmetry? Let me go ahead and make this a little bit larger so you can see it. All right, and let's see if I can do this. It's not going to work well, but it'll do. All right, see how this is 1 unit? So another point of the graph has to be this then. So that has to be 1 unit from the axis of symmetry as well. So there's another point. I just found another point. So here's my y-intercept. If I were to reflect it about the axis of symmetry, I would get this point also. All right, but remember, you need 5 points. Now, I want you to notice something. In this case, remember how the vertex was in the second quadrant and the parabola opened up since A was positive? Are there any x-intercepts? Remember, x-intercepts is where the graph crosses the x-axis. Are there any x-intercepts? No. So there are no x-intercepts. So right here, where it says x-intercepts show work, you would say none. There are no x-intercepts. No x-intercepts. The graph does not cross the x-axis. But you can still graph, and you still want at least 5 points. So here's what you would need to do now. So if you're in that situation where you're trying to graph a quadratic function and there are no x-intercepts, because remember, you need at least 5 points. So far I have 3. Then just use the t-table. All right, so here's what I would do. I would go ahead and write the function over f of x equal 2x squared plus 4x plus 3. Remember that's your function. And just use the t-table. And all you need is 1 point. One more point, and then you can use the idea of symmetry to find the other one. That's all you need. So let's say 1. I would just go 1 more unit from the y-intercept. See how you have 3, and then let's just go 1 more. Let's say 1. So if x is 1, let's see what we get. We get 2 times 1 squared plus 4 times 1 plus 3. I was running out of room here. Plus 3. So I get 1 squared is 1, 1 times 2 is 2, 4 times 1 is 4, plus 3, so that I get 6 plus 3, which is 9. So I found another point on the graph. So another point on the graph is 1, 9, right here. All right, now look. How many units is this point from the axis of symmetry? Well, it is 1, 2 units. So therefore, if I were to reflect it about the axis of symmetry, I would get, again, you go 2 units to the left now. Here's the axis of symmetry right here. So you go 1, 2, and there's the other point. So you found your 5 points, and so you just draw You just draw your parabola and make it look like a parabola now. So if you have use a pencil, and there you go. There's your parabola. There's the function f of x equals 2x squared plus 4x plus 3. All right, so that's what you do when you don't have any x-intercepts, because remember you want to use 5 points. 1, 2, 3, 4, 5 to help you draw the parabola. So if you don't have any x-intercepts, then you just find one more point on the graph, which I found this one, and then use the idea of symmetry to find the other one. Okay? All right, so that was number 1. All right, let's look at number 2. So hopefully number 2 we do have x-intercepts, so we can see what to do with that. All right, now, again, let's find the vertex. So this will be number 2. Now let me go ahead and decrease the size here. All right. Okay, so let's look at number 2. So number two, our function's this. It's f of x equals negative 3x squared minus 12x plus 1. All right, so let's find the vertex. So the vertex, well, first of all, A, B, and C. A is negative 3. Now be careful. Make sure you put the correct sign. So A is negative 3. B is negative 12. And C is a positive 1. So A, B, and C. To find the vertex, remember that's HK. H, remember, is the formula to find that the x-coordinate of your vertex is the opposite of B divided by 2A. So if B is a negative 12, then the opposite of negative 12 is a positive 12. And then 2 times A is negative 3. And so I get 12 divided by negative 6, which gives me a negative 2. So far, I know this. I know that in terms of the vertex, the x-coordinate is negative 2. Now, all I have to do now is find the y-coordinate, which is k. Well, remember to find k, if you know the x-coordinate, all you do, is substitute that back into your function to find the y-coordinate. All right, so I get k equals, basically in this case, f of negative 2. All right, so let's go ahead and substitute. So I get negative 3 times negative 2 squared minus 12 times negative 2 plus 1. So negative 2 squared is a positive 4. Remember, order of operation, you do the exponents first. Negative 2 squared is a positive 4. 4 times negative 3 is a negative 12. A negative 12 times 2 is a positive 24. And plus 1. So negative 12 plus 24 is a positive 12. 12 plus 1 is 13. So my vertex is negative 2, 13. That's your vertex. All right? Okay, now, so in my mind, this is what I know. In my mind. So let's think about this. So my vertex is negative 2, 13, which is up here. So it's in the second quadrant. Okay? Negative 2, 13. And since A is negative, does the graph open up or down? Well, if A is negative, the parabola opens down. And now notice, I have x-intercepts, so I'll be able to find them. I'll be able to find those x-intercepts. Now, I may have to estimate what they are, so I could plot these, but at least I know I have x-intercepts. And remember, in a quadratic function, in all polynomial functions, you're always going to have a y-intercept. There's always a y-intercept. So this will always, when you fill out the y-intercept, you're always going to have something there. You may or may not have any x-intercepts like you saw here, but you will always have a y-intercept. There's always going to be a c there, whether it's 0 or some other value. Okay? All right. Now, so we found the vertex. So the vertex is negative 2, 13. Remember, the domain of every quadratic function is all real numbers. I can substitute any value for x and I'll get a y value. But the range, let's think about the range. Let's use this to talk about the range. So remember, to find the range, that's your set of y coordinates. So we're going to go along the y-axis. Notice that this vertex is a maximum point, and the arrows are pointing down. So I'm going from negative infinity all the way to the largest y value. Now, if this is a maximum point, then the largest y value is 13. Okay? So my range is going to be from negative infinity, parentheses, all the way to 13 with a bracket. That's your range. All right, now remember, your y-intercept, to find the y-intercept, you're going to let x equals 0. But remember, what form is this in? Is this in vertex form or is this in standard form? Well, this is in standard form. So remember, in standard form, if x is 0, that's 0, that's 0, and your y-intercept is your constant. That's your y-intercept. All right, and if you didn't see it, just substitute. All right, so whenever it's in standard form, remember C is always your y-intercept. Now notice a while ago I said, is this in standard form or vertex form? Because in vertex form, don't think that number is your y-intercept. Now what I mean by that is this. All right, so let me get another sheet of paper. What I mean is this. Don't think, see, this is vertex form. Y equal, let's say 2 times x minus 5 squared plus 7. So this 7 is not your y-intercept, because remember, to find x, to find your y-intercept, you let x be 0. So you would say 0 minus 5 is negative 5. Negative 5 squared is 25. 25 times 2 is 50. 50 plus 7 is 57. That's your y-intercept. So the graph will cross the y-axis at 0, 57. Okay? All right, so you got to distinguish between whether it's in vertex form or in standard form. Okay, so your y-intercept, to find your y-intercept, you're always going to have a y-intercept. Always remember that. Whenever you have a quadratic function or any polynomial function, you're going to have a y-intercept. And that's, you have to, because remember, the domain is all real numbers. So at some value for x, the graph's going to cross the y-intercept, because 0, when x is 0, that's in here. 0 is in here. Remember, your x coordinate 0. So at some point, no matter where you are, you're going to have x be 0 and there being a y coordinate. All right, so to find the y-intercept, you let x equals 0. So basically, you're just going to say negative 3 times 0 squared, and you don't have to do that step, because you now know that if it's a standard form, the y-intercept is your constant, is c, which is 1. Minus 12 times 0 plus 1, so you get 0 minus 0 plus 1, which is 1. All right, so there's your y-intercept. So your y-intercept is 0, 1, okay, which is c. So let's go ahead and let's go ahead and plot that point. Now, I'm not going to use this grid here, because remember, it went all the way to 10, negative 10, I'm sorry, 10, 10, negative 10, negative 10. So your vertex is negative 213, so it falls outside of this. So I'm going to go ahead and use a different grid. Let's go ahead and use, let's say, this one. So I'm going to use this one. So far, this is what I know. And I know you can't see this very well. So my vertex is negative 2, 13. So negative 2, 13 is right here. So there's your vertex. Okay? So negative 2, 13 is your vertex. All right. Now, your axis of symmetry, let's go ahead and do that. So we're going to always use the axis of symmetry to help you. So I'm going to draw a dotted line going through the vertex, a vertical dotted line. That's your axis of symmetry. And remember, the axis of symmetry, you had to actually state the equation in a previous lesson. So the axis of symmetry, remember, let me just go ahead and remind you about that. So the axis of symmetry, remember, is a vertical line. And remember how to name a vertical line. It's x equal. Okay, vertical line is x equal, and notice that this vertical line is x equal, and then notice that's a -2. So it's x equal -2. So it's actually the x coordinate of your vertex, your axis of symmetry, x equal -2, right here. Okay, now the other thing I know is this. I know that the y-intercept is 0, 1. Okay, so I'm going to go ahead and plot that. So here's 0, 1 right here. So there's my y-intercept. Now remember, let's talk about symmetry. So here's your axis of symmetry right here. You can't see it very well, right here. And then ask yourself, remember, it's symmetrical about your parabola is symmetrical about the axis of symmetry. Okay, so if this is my y-intercept, remember you're always going to have a y-intercept. So use that distance to find the other point, because remember you need 5 points. All right, so how many units is this from the axis of symmetry? How many units? 1, 2. So let's go 2 units to the left. 1, 2. So there's the other point. All right. Now remember, the parabola opens down, so am I going to have any x-intercepts? Yes, I will. So let's go ahead and find them. All right, so that may be a little bit more involved to find the x-intercepts. All right, so let's talk about this. Okay, now listen carefully to this. So to find the x-intercepts, remember to find the x-intercept, that's where the graph crosses the x-axis. Well, remember in a previous lesson, the graph crosses the x-axis, no matter what your function is, whenever your graph crosses the x-axis, the y-coordinate is 0. Right, so the y-coordinate is 0. All right, so here is my function. Y equal, I'm going to go ahead and rewrite f of x as y. Y equals -3x squared minus 12x plus 1. All right, now remember, to find the x-intercept, you're going to let y equal 0. So if I let y equal 0, this expression here is equal to 0. So I get -3x squared minus 12x plus 1 equals 0. Okay? All right, now I want to solve. Now notice now, this is now, see how this is written as a quadratic function? This is now written as a quadratic equation. And so I want to solve this quadratic equation because I want to find out what those x-intercepts are. So your x-intercepts is where this is equal to 0. So I got to solve this quadratic equation. So I'm going to use the quadratic formula. But first of all, let's remember what a, b, and c are. So a is -3, b is -12, and c is 1. Now keep in mind that if any of this is incorrect, then obviously your x-intercepts will be incorrect. But when you go to graph them, you'll see that those are incorrect because it won't look symmetrical anymore. Okay? So use the idea of symmetry. When doing this part here, this is going to be the most work right here. The most work. To see if these are correct, it should be symmetrical with respect to your graph. Okay? So if for some reason, you see how, if for some reason you have something that looks like this, you know obviously your parabola doesn't do that, right? So it's got to look like a parabola. So if it doesn't look like a parabola, if it's not symmetrical, then obviously there's something wrong here. All right, so let's keep that in mind. All right, so remember your quadratic functions, the quadratic formula is this. So it's the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. All right? All right, so here we go. The x-intercepts is going to equal the opposite of b. Well, b is -12. The opposite of b is a +12, plus or minus the square root of b squared. Put that in parentheses. -12 squared minus 4 times a is -3, times c, which is 1, all divided by 2 times a, and a is -3. All right, now remember, just like, and you had this idea in a previous lesson and on a previous test. So remember, the reason why I put this in parentheses is because you're squaring a -12. So -12 squared is a positive 144. So I get 12 plus or minus the square root of 144. A -4 times a -3 times a +1 is a +12, all divided by -6. That's where I'm at. All right, so we're going to take the calculator out because you're going to need your calculator. So this becomes 12 plus or minus the square root of 144 plus 12 is 156, all divided by negative 6. Now remember, in a previous lesson, when you had to solve quadratic equations, remember you had to simplify the radical? Don't do that here. Don't worry about simplifying the radical, because all you want to do is make an estimate of where these x-intercepts are. So you need to round, you have to round this to the nearest tenth. Okay? All right, so let's go ahead and do that. So all you do is this. All right, so let's see how to use your calculator with this. All right, now listen carefully. Here's the way I would do this. Let's find the numerator first. Okay? Now remember, this is, we're going to do the plus first and we're going to do the minus. So let's do the plus first. So remember, this is what you have. Remember, this says 12 plus the square root of 156 divided by negative 6. And the other one is 12 minus the square root of 156 divided by negative 6. Okay? All right, so 12, let's do this one. 12 plus square root's right here, so remember how to get to it. And notice to put parentheses there. 156. And since all I'm doing is just finding the numerator, you don't have to put that in parentheses. You'd have to close it, but just close it if you want to. And then press equal. Now don't press divide. Don't say divide by negative 6, because then you're going to have an error. Because if you divide by negative 6, the only thing that's being divided by negative 6 is this square root, is this radical right here. But this whole thing has to be divided by negative 6. So that's why, listen carefully. Find the numerator first, just like this, and then press equal, just like this. So that's the numerator. Now don't leave it like it is. Don't do anything else. Then you say, all right, now that's the numerator. Remember, I got to divide that now by negative 6. So divide by negative 6. And make sure you use the negative button and not your subtraction button, because you're going to get a syntax error. And then press equal, and there is one of my x-intercepts. So I'm going to say approximate equal to, let's do the nearest tenth. That's negative 4.1. Negative 4.1. Okay, let's find the other one. Now remember our discussion again. Let's go through the discussion. 12 minus the square root of 156. Remember, that's the numerator. Don't say divide by negative 6, because the only thing you're dividing by negative 6 is this radical. So let me just kind of go back to this and just show you. If you had done this, I'm going to show you. If you had said 12 plus the square root of 156, and then say divide by negative 6, look at what you would have gotten. Let me make sure I did. So it's like 9.9. All right, so obviously you know that's not the correct x-intercept there, because look, if you did say that, see where it's 9 point, so obviously you know it's not going to do this, right? That doesn't look like a parabola. All right, so be careful. All right, now let's go here. 12 minus the square root of 156. Close the parentheses. Now press equal. That's the numerator. Press equal. Do that now. Then you're going to say, so that's the numerator right here. Don't do anything. Leave it there. Then say divide by negative 6. Make sure you use your negative button. And I put negative 3, so I meant negative 6. So let me just change that to 6. And then press equal. And the other one is approximately equal to 0.1. Okay? All right, so those are my two x-intercepts. So in the blank, you would say x-intercepts are, remember this is approximation, so it's okay to say negative 4.10, and the other one is 0.10. They're probably going to ask you to write in ordered pair. If not, then it's okay to just say your x-intercepts are negative 4.1, comma 0.1. Okay? All right, now let's see if this kind of makes sense. All right, so I'm going to zoom in just to give you a better idea. So let's see how this is going to look. So I'm zooming in, and this is as far as I can go. All right, so we have negative 4.1 as one of the x-intercepts. So this is negative 4. The negative 4.1, just approximate, is about here, right? And the other one is 0.1. Remember, 0.1, that's positive, and it kind of makes sense that to be positive because here's your y-intercept. So the rest of the graph has to be on this side. So here we go, right here. All right, and then kind of estimate. See how this distance here, does that kind of look like this distance here? Yeah. All right, so you found your x-intercepts, and so then I'm going to go ahead and zoom out. All right, so let's do the best we can with graphing these. So here's the vertex. So do the best you can. Just make it look like a parabola. Using a pencil, so you can erase if it doesn't look good. All right, so I'm going to go back and darken it a little bit better. Just do the best you can. All right, and then do the same thing here. Do the best you can. Kind of get it to that y-intercept. There we go. And then down like this. Okay? All right. So there's your parabola. Okay, so notice it took quite a while to kind of get through this process. Okay? Now, usually the one, though, on the test or final, the x-intercepts are integers. They're not irrational numbers like these were. They're going to be integers to where they're going to look fine. All right, but that's what you do. All right, now I'm going to go ahead and do another. I'm going to do two more problems, but I'm going to put that on a different video since this video is closing in on 40 minutes. All right, so before you begin the worksheet, look at the next two problems.